अस्सलाम वालेकुम टू ऑल माय डियर स्टूडेंट्स। लास्ट टाइम हम लोगों ने डिस्कस किया sp3 हाइब्रिडाइजेशन, sp2 और आज हम पढ़ने जा रहे हैं sp हाइब्रिडाइजेशन। तो sp हाइब्रिडाइजेशन क्या है? इसमें जो s है ये भी 50% इसका करेक्टर होगा और जो p है वो भी 50% करेक्टर होगा। अब s p d f इनको हम क्या नाम देते हैं? ऑर्बिटल्स का इनको हम नाम देंगे। तो sp हाइब्रिडाइजेशन क्या है? सबसे पहले हम इसको डिफाइन करेंगे। द process of mixing of 1s and 1p atomic orbitals, 1s and 1p atomic orbitals to give two hybrid orbitals. The newly formed orbitals are called hybrid orbitals. According to the rule of the hybridization, number of mixing orbitals, they are always equal to the number of the newly produced orbitals. Like here we are going to mixing the two atomic orbitals and two hybrid orbitals are formed. sp hybridization it clearly explain divalency of beryllium Be. For example, beryllium, the atomic number of beryllium is 4, electronic configuration 1s 2, one electron is clockwise and other is anti-clockwise, 2s2, 2px that is empty, p has 3 degenerate orbitals, p has 3 shapes, 2px along x-axis, 2py along y-axis and 2pz along z-axis, that is low energy state, and low energy state is called ground state. Beryllium forms 2 bonds and we know that bond formation is energy releasing process. That energy is utilized to excite the beryllium atom, and one electron will shift from 2s orbital to 2px orbital and electronic configuration become 1s2 2s1 instead of 2s2, 2px1, 2py0 and 2pz also empty, that is high energy state, and high energy state is called excited state. Because here we are discussing about the sp hybridization, here s character is 50% and p character is also 50%. 1s and 1p atomic orbitals, they joined to each other to give hybrid orbitals, and we know that two sp hybrid orbitals are formed. Two sp hybrid orbitals are formed, and these two sp hybrid orbitals have same shape and same energy, and according to the Hertz rule, if two same energy orbitals are available, then electrons will prefer to reside in a separate orbital with the same spin. Each will have one electron, that is called hs. hs stands for hybridization state, excited state and ground state. After excitation and hybridization process, it takes place simultaneously. For example, here 2s orbital, s is always in spherical in shape, 2s which participate in the determination in hybridization, and 2px along x-axis, that is 2px, 1s and 1p, these are mixed to each other and to give sp hybrid orbitals, and each will have one electron, and these are two sp hybrid orbitals. Now these two sp hybrid orbitals, they orient in such a way that repulsion is minimized, and the repulsion is minimized at the angle of 180 and shape will become linear. 180 and shape become linear. Suppose that the first example is beryllium chloride. These are two sp hybrid orbitals. sp hybrid orbitals which orient in such a way that repulsion is minimized at the angle of the 180. sp hybrid orbital having one electron, also sp hybrid orbital having one electron, that is sp hybrid beryllium. Like chlorine, the atomic number of chlorine is 17 and electronic configuration become 1s2, 2s2, 2p6, 3s2, 3px, 3py and 3pz, 12, 13, 14, 15, 16 and 17. Just one orbital contain unpaired electron, that is 3pz. It is the beryllium which is sp hybrid. Beryllium which is sp hybrid having two sp hybrid orbital, and that is 3pz of one chlorine. 3pz of one chlorine contain one electron, and other 3pz of second chlorine, 3pz of second chlorine also contain one electron, and here that is the overlapping of sp and 3pz atomic orbital, that is linear overlapping. And we know that the bond which is formed due to the linear overlapping of partially filled atomic orbital, the bond which is formed due to the linear overlapping of partially filled atomic orbital like sp and 3pz, that is sigma bond and also sigma bond, and it is the beryllium atom here in center, that is beryllium, chlorine with sigma bond, chlorine also with sigma bond, angle is 180 and shape become linear, that is the structure and shape of beryllium chloride. And sp hybridization easily explained divalency of beryllium. Other example is also known as ethine YNE, triple bond. The atomic number of carbon is 6, electronic configuration become 1s2, 2s2, 2px, 2py and 2pz. Low energy state is called ground state, 4, 5, 6 and empty. Carbon forms 4 bond, and bond formation is energy releasing process. That released energy is utilized to excite the carbon atom, and one electron will shift from 2s to 2pz atomic orbital, and electronic configuration become 2px1, 2py1 and 2pz1, and here 2s1, that is high energy state. Excited state, after the excitation mixing of orbitals takes place, and that is called hybridization state, because here we are discussing about sp hybridization. 1s and 1p atomic orbitals, they are joined to each other, and these two unhybrid orbitals which don't participate in hybridization, but they participate in the formation of pi bond are in overlapping. Suppose that 1s and 1p, they will give us two sp hybrid orbital, and each will have one electron, and these two sp hybrid orbitals, they will orient in such a way that repulsion is minimized at the angle of the 180 degree and the shape become linear. If we see in the structure of the acetylene, here sp hybrid carbon having one electron, sp hybrid carbon having one electron, also sp hybrid carbon having one electron, and sp hybrid carbon having one electron. That is the overlapping between carbon and carbon atom, and that is linear overlapping, and the bond which is formed due to the linear overlapping of partially filled atomic orbital, that is called sigma bond. Here it is the sigma bond between carbon and carbon atom. And we know that hydrogen, the atomic number of hydrogen is 1, electronic configuration 1s1, that s atomic orbital of hydrogen, also hydrogen s, and overlapping linear between s and sp, carbon and hydrogen, linear overlapping, and the bond which is formed due to the linear overlapping, that is sigma, and also sigma here. These two sigma bonds are present between the carbon and the hydrogen, carbon and hydrogen, that is between carbon and carbon. Each carbon has two unpaired electrons. Each carbon has two unpaired and unhybrid orbital, 2py and 2py, 2py and 2py. They can be shaded just for differentiation, 2py and 2py having one electron, and 2pz also 2pz and 2pz. These 2pz, they can be dotted for what purpose? Just for the differentiation, not any specific chemistry, just for the differentiation. Here shaded orbitals are 2py and dotted orbitals are 2pz. And we know that 2py and 2pz atomic orbitals, 2py and 2pz atomic orbitals, they will parallel overlap to each other. Just that is linear head-on approach, and that is sidewise approach, parallel overlapping. And we know that the bond which is formed due to the parallel overlapping of orbital, that is called pi bond. Here 2py will parallel overlap to 2py, half pi bond above and half pi bond below. 2pz will parallel overlap to 2pz, half pi bond above and half below, across the line joining of two nuclei, and that is overlapping. 2py overlapped to 2py, half electron density above and half electron density below. Similarly 2pz and 2pz, half pi bond above and half below. In acetylene carbon and carbon contain triple bond. Carbon and carbon contain triple bond. That one sigma bond, due to the linear overlapping of sp and sp, carbon and carbon, and these two pi bonds are formed due to the parallel overlapping of 2py and 2py and 2pz and 2pz, and these sigma bond between carbon and the hydrogen, also carbon and hydrogen. That is the total examples of on sp hybridization. I hope that that lecture will very interesting lecture for you and will increase your knowledge. Thank you very much.